My name is Gyan and I have my colleague Umar. Together we'll be exploring the world of provable programming through Cairo. It's a bit of a long title, but I have bolded things that are basically important. That is provable programming and Cairo. The agenda for today is why Cairo before learning any new programming language, especially in the Web3 space. I feel like everybody should ask this question to themselves. Why should you learn another new programming language and what does it bring to the table? We look at what are validity proofs and how are they solving the scalability problem, and then all about Cairo with Omar. Thank you. So why Cairo? I just have one slide for it and try and explain this in a scenario that's best understood by developers. When when you write a program in any programming language, you execute the program and you try to get a result for that program, right? Most of the times, this is how you are this is how you have been seeing systems running so far. However, if you want to make sure that you want to prove that something was done correctly, then you want to create a proof out of that program, right? And most of the programming languages that exist as of today do not allow you to generate that proof. However, when you write a program in a programming language like Cairo, when you execute this program in any supercomputer, for example, in this context, or any computer for that matter in the world, it will not just execute that program, it will also generate a result and a proof for you. Now, this slide is actually has a little bit more context, but because of the shorter workshop today, imagine if this supercomputer exists in a rival country and you have given them a piece of code to execute, right? You want them to give you the result and you want to make sure that the result is accurate. If the rival country tries to manipulate the result, whether it was intentional or unintentional, you will come to know because along with the result, a proof is generated. So the idea of Web3 or the idea of blockchains is to be able to create trustless cooperations, right? You want to be able to trust any source or any machine that runs a piece of code. And the best way to do that is for that machine to be able to prove that I have run the exact same algorithm that you have given me. This is exactly what proof systems do. Proof systems help not only generate a result for your algorithm, from your algorithm, but they also generate a proof that I ran the same algorithm that you gave me. And you might have heard of zero-knowledge proofs, you might have heard of provers and verifiers, which is what is used in zero-knowledge proofs. And this is what exactly the provers do. They generate a proof that a certain computation was done authentically. So in case the computation was tampered, whether intentionally or intentionally, the proof generated for that computation will be invalid. And this is how, in a zero-knowledge proof or in a validity proof scenario, a regular computer is able to keep a supercomputer honest. The crux of all of this is that in order to generate a proof, you need to learn a provable programming language, which is what Cairo is. Cairo is a powerful and a highly performant programming language, which is not just used in Starknet, but can also be used as a standalone provable programming language. That's why we chose to phrase the talk today as explore the world of provable programming through Cairo. How are validity rollups solving the scalability problem? And why should you build on Starknet? That's the next question, right? When you think of the L1 scaling problem, you have Ethereum, where, say, for example, when you're producing a block, it just says that, hey, like, you remember the problem where we are saying like, okay, here is an algorithm, we are executing this algorithm. The new state of the system is 42, right? And a lot of books also say that the answer to all world's problems is 42. Well, we can only hope. And what happens in the system is The validators actually validate whether this new state is correct. And how do the validators validate? They're going to rerun the entire computation that this particular block producer actually ran in the first place. And I'm sure all of you already know that Ethereum has gotten congested more often than not in the past couple of years, especially when there's been huge launches, etc., etc. And that's a huge bottleneck in L1s. Whereas, when you think of proof systems, if you remember, in a programming language like Cairo, you can not just generate a result saying, hey, the state of the new system is 42, but you can also generate a proof that how the state of the system became 42. And what happens at Ethereum level, right? So you can see there are two distinctions here. One is the sequencer and one is the validator. Now, sequencer is what is sitting at the layer 2 at Starknet, which is producing this new block. And it is also able to create a proof. Now, the validators, instead of having to rerun the entire computation, we'll just have to verify the proof that is generated by the sequencer. And the time taken, as you can see, is pretty less than what it takes to actually rerun the entire computation. Not just Starknet, but almost all of the zero-knowledge proof mechanisms that you're looking at, or validity roll-up mechanisms that you're looking at, use this exact mechanism to achieve scalability for Ethereum. And that's why you should learn about Starknet, that is validity proofs. Validity proofs are an implementation of zero-knowledge proofs. To say that they are zero-knowledge proofs is actually a misnomer. It's not correct because Starknet is a decentralized layer 2, which is a public network. So it's not entirely a zero-knowledge proof system, but it adapts from the mathematics of zero-knowledge proof systems. It takes from the arithmetics of that and is built on top of that. And because it validates in a way that is based on the prover-verifier system, that's why we call them validity proofs. They use ZK proofs to guarantee computational integrity. That means you can always say that a particular computation was correct or not just by being able to validate or invalidate the proof. What this means is doing the right thing even when no one is looking, which is the ethos with which Web3 was created, right? We placed our trust into code and not middlemen because we want everybody to be able to do the right thing even when no one is looking. There's a lot of misunderstanding when it comes to what you can build on things which are built on top of principles of zero-knowledge proofs, because zero-knowledge proofs are generally considered to have more privacy use cases, but that's not the truth in this case. Starknet itself, it's all about scaling, right? So you can just about build anything on Starknet. A lot of people came to our booth asking if we are leaning towards a particular domain. And my answer is, surprise us. If you're building on Starknet, build anything cool, and we are more than happy to, see what you're building. Like I said, ZK rollup is a misnomer and Starknet is a validity rollup. It uses a particular algorithm called Starks, not Snarks. Two advantages of Starks I want to quickly run through before passing it over to Omar. The first one is that Starks are post-quantum secure because they don't rely on elliptic curve cryptography. They rely on collision-resistant hashes. And the second is Starks do not require a trusted setup, whereas Snarks do. So they are decentralized from the get-go. Cairo is the programming language that we are using right now to be able to write contracts, to deploy on Starknet, and the next session is all about Cairo.
So, thank you very much. Now we know the relevance of Cairo, what started this for, and now let's look at some Cairo. Who is here considering building something on Starknet for this hackathon? Okay, so most of you. Okay, so today, who of you have already written Cairo? Who has written Cairo before? Okay, so, okay. What is your name, sir? Danilo. You know who Danilo is? He's building the zero-knowledge EVM called Kakarot, which is using Cairo for building a zero-knowledge EVM. So what Gian was saying was very relevant. You can build a zero-knowledge EVM on top of Cairo and Starknet. So this is very, very interesting. You can do a lot of different stuffs. And to be honest, we won't be able to learn how to write Cairo right now in these 20 minutes we have left. But there's our booth, and feel free to come, and we will see more details about it. We'll go like with an overview right now, but feel free to come to our booth downstairs, and we can guide you, we can help you, and you can build some very cool projects. For example, some guys, which I don't know, they are not here, but they came out and asked us if there's something like auto payments they can implement on Starknet with Cairo. An auto payment is, for example, when you subscribe to Netflix, and Netflix makes you a charge every month without you don't authorize it. You authorize it once, and then you don't have to keep signing the transaction each month. It's automatic, and that's thanks to account abstraction. That is something that we have natively in Starknet, and it's something that we have been working on a lot of time with Open Zeppelin, Bravos, Argent, members from the Ethereum Foundation. So we have been working hard on account abstraction, and that is something that I don't know if you can build it with that quality on other place that it is not Starknet. And you can do all that with Cairo. So Cairo basically is a smart contract. It's a language that is very similar to Rust. Who knows Rust here? Rust. Perfect. For you, it's going to be very, very simple. But don't worry if you don't know Rust. It is very doable. Who knows Solidity here? Okay, if you know Solidity and you know how a smart contract works, it is very simple. So I will go and see a small smart contract here, and also point you to a place where you can learn more. I love learning in a written way. So if you want to install everything you need, your setup in order to build on top of Cairo and Starknet, if you scan this QR code, you will go to the Starknet book. As with the Rust book, you will have everything you need to start coding. The syntax of Cairo, the setup, the CLI in order to interact with the network, some tooling. You can write your contracts using Starknet.js, which is an SDK that will be similar to whatever you use in JavaScript to interact with Ethereum. You can do it with Python, you can do it with Rust. So we have different SDKs. Everything you can find in the Ethereum ecosystem, you can find it here. And this is the guide for you. This is the guide for you to install everything and then start writing Cairo contracts. And you will be able to go for this hackathon. Again, you can ask anything you want downstairs. Actually, one of the creators of Cairo is down there with us. So who better than him to answer your questions? And let's look how a smart contracts in Cairo looks. If you go to the Starknet book, this is the Starknet book, the one you already scanned the QR code, and you will go to chapter number 2. Inside here, you will have the fundamentals of Cairo. Cairo applied for Starknet because it's different, right? And here is a small smart contract that will allow you to vote. It's a voting contract, just an example. But this example will get you going. So let's start. Okay, I will import with use Starknet. Starknet is the library that contains everything related to Starknet. I'm gonna import the contract address. Okay, that's very similar to Solidity. And then, as in Rust, we're gonna define a trait. This trait is going to contain all the functions that are going to be external functions. What I mean with external functions? The external functions are those that interact with the memory or the state of the smart contract. Okay, those that can read or write from the state. For example, this is the trait vote trait. T here makes reference, in this case, to the state of the smart contract. Okay, so we are receiving here the state of the smart contract, and then we're going to be interacting with T. So again, T in this case is the state of the smart contract. Then we have this function called getVoteStatus. I want a function that is a getter function for those that already know Solidity. It's going to be reading from the storage, and it's going to get me the status of a vote. How many yes, how many no. It will make a reference pointing towards the storage. Okay? Why? Because I don't need to write on storage. For those of you who knows Rust or memory management, this is very familiar to you. So here we're referencing the storage because we need to read from it. We don't need to write on it. So it is basically a read function or a getter. And it will be returning 4 different U8s, unsigned integers, 8 bits. Okay. This is also another getter function. It will be reading from the storage, and it will tell me if a voter can vote. It will receive again the storage of the contract, and will receive the contract address of the user that I'm asking for. Can this user vote? I will give it the address, and it will return a boolean, true or false. And we have the same with, is a voter registered? Yes or no. In this case, 1 or 0, because it's a boolean. It looks like that. And finally, we have an external function, but it is a write function. Okay, this write function, which is vote, it references the storage, but it is not only like a reference to read from the storage, but it can write it. It can alter the storage. That's what I'm telling with this. Notice the difference between this and this. Okay, these are getter functions, only reading from the storage. This is writing to the storage, and it will also receive the vote, an unsigned integer, 8 bits, yes or no. In this case, it would be 0 or 1. Okay. Then we'll be implementing this trait. So we're defining here the storage, the functions that are going to be interacting with the storage, either by writing or by reading. And then finally, we go into the Starknet contracts. This is going to be a mod called votes. That is the name of the smart contract. Then we will import a couple. We will import the contract address from the Starknet, and we're going to import the function called getColorAddress. I don't need to explain those. Those are very similar for you. We have two constants, one that represents a yes and a no. Those are U8. And they are 1 U8. This looks a lot like Rust for those of you that have already seen it. But it is very simple. If you don't know Rust, no problem. Then we're going to go to the storage. This storage is very simple. You can read for a moment and you will understand it. We have yes votes, no votes, can vote, which is going to be a boolean. It's going to be mapping. This is a mapping like in Solidity, a contract address to a boolean. Registered voter is going to map a contract address with a boolean again. And yes and no votes are simply unsigned integers. Until now, is there a question? We have seen how to create the trait for the functions that are going to be interacting with the storage. We have started our own smart contract, and we have defined the storage. The next is going to be easier. So, is there any question here? Yes. Yes, you won't even notice it, but behind it is building everything you need in order to interact with Cairo.
Okay,
No, on the contrary, it's very, very cheap. So the goal here is that we are having a network that is going to be very cheap to use and also very fast. We had a recent update to the network last week actually, which increased a lot the TPS from the network. Like I think right now is the fastest zero knowledge network there is. It's to be honest, this is going to be increasing a lot in the next month. So congratulations for being here, because to be honest, we are on a very good spot right now with Starknet, and this is going to be even better. Okay, so I will proceed. Again, there might be more questions, but we can meet downstairs, no problem. Then I have the constructor. This for you is very similar if you know Python, Rust, I don't know, JavaScript, if they have something like a constructor, but simply what we're doing is initializing the smart contract. So the constructor, when we deploy it, we are asking for 4 things. First, we're asking for the contract state. Again, this we can modify. So I asking for the state, and I'm going to be able to modify it. And I'm going to ask for 3 contract addresses for the voter number 1, voter number 2, and voter number 3. We only have a smart contract for 3 different addresses to vote. This can be infinite, 4, 5, whatever. In this case, in this example, we only have 3. Then we are doing some stuff in the initialization. We're calling functions inside our smart contract using self, and calling internal functions like register voters in here. I will show it in a minute, but to me this is very important. Here I am altering the state of the smart contract. I am writing to it. Okay, so what I'm doing here is self. On this smart contract, that is self, go to the yes votes, which is on the storage here. This is the yes votes variable in the storage. And then write the number 0, but 0 in a format of a unsigned integer of 8 bits. Sorry, I'm making some zoom here. Do the same with no votes. What I'm doing here is basically saying, hey, the voting contract is going to start with 0 votes with no, 0 with yes. Okay? So write to the storage that we don't have any votes with no and no votes with yes. That's basically it. And we're also registering the voters, like voter 1, voter 2, and voter 3 can vote. That's all. We're saying these guys can vote, and we're initializing the vote count with 0 and 0. Then we create an event. This is how events look like in Starknet and Cairo. I won't go into details right now, but again, you can go to the book or you can read this in the book starknet.io. I will give you the URL in case you want to review it. But this is how an event looks like. Okay? Then I want to show you how to implement the functions that we actually defined before in the trades. Okay? So we create an implementation of that is going to be called vote impl. This name can be changed. It can have any name, no problem. This is an implementation of super, which means it's an implementation of something that is in this file, which is called vote trades. And it's going to be receiving the contract state. If you go to what is vote trades, vote trade is the trade that we define at the beginning that contains all the functions that are going to be external functions. Okay? So we are now implementing all these functions. Here I am defining a gate vote status look like this. It receives this and returns this. Well, I'm not telling you how to implement it. Okay? So now we're going to implement it, and yes, that's all. Here's a function. You can see it here. It is get vote status. We've mentioned it before. It is not going to be writing to the storage. It's simply going to be reading from the storage. And it will be returning me 4 unsigned integers of 8 bits. And then I start writing the function. As you can see, it's nothing. It is nothing out of this world. Let's call in this function with self. The self because simply it is referencing to something that is inside this smart contract. Then we're defining the yes storage and no percentage. It looks like, for those in Python, it looks like a tuple. It's actually a tuple. And then we call a function, and that's it. I think you can understand this. It's very, very simple. Then we implement another getter function, which only reads from the storage. We do the same here. And this is very interesting to me. This is the external function that actually writes, which is the vote. So it alters the storage. It says this number of votes were with yes and this with no. And basically it receives a vote. Then it has an assertion, which is very useful in Cairo for finding errors in your code. So we assert that the vote should either be no or yes. Otherwise, it will return this error, vote 0 or 1. This is an error that will be returned if I vote with 2 or 3 or 4. It won't understand it and it will return this error and it will stop. Then we start calling some functions, but again, this looks to you very similar to Solidity, okay? Or any other programming language. It's very simple. And basically, then I do the same with another set of functions, and that's it. That's basically it. This is the Cairo smart contract. Right now is, to be honest, very simple. If you know Python, or you know Rust or Solidity, this to you is very simple. So, sorry we couldn't go through a lot of details, but again, we will be downstairs tomorrow, today, and the day after tomorrow. We will be there answering any question that you can have. And please go to the book starknet.io. Let me give it to you. This is the QR code to the book, where we have most of the content you need to do this. You will have the voting contract plus other examples. If you are willing to implement a construction, you also have a construction examples. We have all the tooling you need. If you write Python, JavaScript, Rust, whatever, you will find it there. If not, please let us know. All the tools are there. The future for us is going to be scalable, and we really believe we're building stuff for the next 20 years. And Starknet, we think, is a great solution. To me, it is the way to go. And yes, let us know what you think. And yes, thank you very much. Thank you to Jan, and thank you for coming. If there's any question, I can see we have a couple minutes. Cool swag. So we have a Telegram group which is of high quality, where we have a lot of builders in Starknet, so you can feel free to ask stuff. Go write some Cairo. Let us know that you're writing Cairo, and we can help you in different ways, right? So go explore it, feel it. If you like it, let us know. If you don't like it, also let us know, and we can support you. We are here to help you. Our goal is to get as many developers as possible. We're not interested right now in investors or in that many users, financial users per se. We are more interested in building right now. So if you're a builder, let us know, and we can help each other. So just very quick, to deploy is very easy. She asked how to deploy, and you will find everything you need here in the Starknet book in this QR code. You will find in the introduction to Starknet your first smart contract, first Starknet contract, and then you will find everything you need here to deploy. You have to create a signer because we're using a account abstraction, somebody that signs for the transaction. You have to declare it, which is a different concept, but you will find it here, then deploy it. But yes, here you will find everything you need. Sorry.
Yeah, so I'm trying to figure out in practice what use case could run on Starknet that I couldn't run, let's say, on a regular EVM chain. If I understand correctly, this is one of the fastest of the zero-knowledge chains. But doesn't mean there are some things I can do in this chain that I cannot do on the others, or is it just faster than what?
Yes, imagine you have a bigger computer. So whatever you think requires more computational power, I think this is a use case. For example, right now we are building a lot of autonomous worlds for gaming, on-chain gaming, where all the regulation is made on-chain, all the operations are made on-chain. Also, because it's cheap and it is fast, you can do AI on-chain. This is something that I have not seen done on-chain. It's something that is weird. I don't know if somebody knows about on-chain AI. Build all the calculations on the chain. That is something that's something hard to implement because of the cost, of the velocity. So I think that if you can think in something that requires a lot of computation, this could be a use case. Of course, I'm not saying that this is good for everything. You don't want to kill a fly with a bazooka, right? So you have to think about it, but yes.
Yeah, so we actually want to use it for AI, but as far as we understand, if we use zero knowledge for AI, it increases computational cost by like 100, even 1,000 sometimes. So is that something that would happen in Starknet as well?
Actually, Danilo is working on that, right? And can you? Also, you want to do some AI, I recommend you check out Orion from the GZ Tech company. They're using Starknet and Cairo to build some AI. So they are actually in this hackathon right now. and you can meet these guys. These guys are genius, and they are making on-chain ML. And here we have a lot of different tutorials on how to use their models. And this is something that I think is going to be the future. In the next year, we will be talking about this, and I think this is a great opportunity to win a hackathon, right? It sounds very impressive. AI on-chain. Okay, thank you very much. We'll be downstairs, okay? Thank you.